example. So evaluate the surface integral where S is the surface of the sphere x square plus y square plus z square equal to 1. That is the unit sphere, right? And the parametric equations of the sphere S are, yes, x is equal to r sine of theta cos phi. But because it is a unit sphere, so r here is equal to 1. The radius is 1. And then y is equal to sine of theta sine phi, and z is equal to cos of theta. Writing this given surface integral to be equal to the double integral over S x cube dy dz plus y cube dz dx plus z cube dx dy. A very easiest way to understand this is your I vector, this is your j vector, this is your k vector. Writing here dx, dy, dz. Just for the understanding, when you are considering this I vector, that is the first component, then you have to write, you ignore this and write dy, dz with the first component. Similarly, when you are considering j vector, then just ignore this and write the product of dx, dz with the second component. And when you consider k vector, then just ignore this and write the product of dx, dy with the third component. By the rule of the change of variables, for the integral, we write here x cube into, this is dy dz, so you have to write curly yz divided by curly theta phi plus y cube, this is dz dx, so write curly zx divided by curly theta phi plus z cube, so writing here curly xy divided by curly theta phi d theta d phi. In case of the unit sphere, the limits of theta are from 0 to pi and the limit for phi is from 0 to 2 pi. In the previous example, we have taken the limits of theta and phi to be from 0 to pi by 2, right? But there the surface of the sphere is in the first octant. And in this example, the surface of the sphere is given to be a complete unit sphere. So here we take the limits of theta from 0 to pi and for phi from 0 to 2 pi, right? Please understand this. Now we need to calculate the values of these three terms. So calculating first curly yz divided by curly theta phi, and this is the determinant. So this is equal to, derivating y with respect to theta, we get cos theta sin phi. Derivating y with respect to phi, we get sin theta cos phi. Derivating z with respect to theta, we get negative sin theta. And derivating z with respect to phi, we get 0. So on solving, we get sin square theta cos phi. Then is curly zx divided by curly theta phi. Derivating z with respect to theta, we get negative sin theta. Derivating z with respect to phi, we get again 0. Derivating x with respect to theta, we get cos of theta cos phi. Derivating x with respect to phi, we get negative sine of theta sin phi. And the determinant is equal to, this is sine square theta sin phi, right? And then calculating curly xy divided by curly theta phi. Derivating x with respect to theta, we get cos theta cos phi. Derivating x with respect to phi, we get negative sine theta sin phi. Derivating y with respect to theta, we get cos of theta sin phi. And derivating y with respect to phi, we get cos theta cos phi. On solving this determinant, we are getting this to be as sine of theta cos theta. And now putting all these values in this first integral, so we get double integral from 0 to pi and from 0 to 2 pi x cube. So that is sine cube theta cos cube phi. And then the value for this, that is sine square theta cos phi. Sine square theta, so this power becomes 5. And cos phi, that is, it becomes cos the power 4, right? Plus y cube. This is sine cube theta sine cube phi. And the value for this is sine square theta sine phi. So for sine square theta, this becomes the power 5. And for sine phi, this power becomes 4 again. Plus z cube. So this is cos cube theta. And the value for this is sine of theta cos theta. So this is sine of theta, and for cos theta, this power becomes 4. D theta d phi. We are going to integrate this first with respect to theta. And because I need to use the reduction formula, and the reduction formula can only be used if the limits are from 0 to pi by 2 for theta. So for that, we need to multiply this complete integral with 2 so that I can get here limits from 0 to pi by 2. Now I'm going to use the reduction formula. I'm having the power of sine theta to be as 5. So subtracting the odd numbers from this power, 5 minus 1 is 4, 5 minus 3 is 2, and 5 minus 5, 0, not required. Divided by the power 5, and then subtracting the even numbers. 5 minus 2 is 3, 5 minus 4 is 1. And writing cos the power 4 pi as it is, because we have used the reduction formula for theta here, right? Plus again sine the power 5 theta. So this is again 4 into 2 divided by 5 into 3 into 1. And writing here sine the power 4 phi. Plus now using the reduction formula for this product, the power of cos theta is 4. So 4 minus 1 is 3. 4 minus 3 is 1. Let's stop here. And the power of sine is 1. So 1 minus 1, 0, not required. Divided by, here I'm having the power 1. We have to add these two powers for the denominator and then subtracting the even numbers from this power. That is from the addition of this power, that is 5. So 5 minus 2 is 3 and 5 minus 4 is 1. Let's stop here. And writing d phi. So this becomes 8 divided by 15 cos the power 4 phi. So this is equal to twice from 0 to 2 pi. 8 divided by 15 cos the power 4 phi. Then again 8 divided by 15 sine the power 4 phi. Plus 8 divided by 15 sine the power 4 phi. Plus, and then is this 3 will go and we get 1 divided by 5. D phi. Now let's multiply 2 with each term. We get 16 divided by 15 integral 0 to 2 pi cos the power 4 phi d phi plus 16 divided by 15 integral from 0 to 2 pi sine the power 4 phi d phi plus 2 divided by 5 0 to 2 pi integral d phi. Now again we have to use the reduction formula over here, but for that the limits should be from 0 to pi by 2, right? But because I'm having here 2 pi, I need to multiply this integral with 4 to get pi by 2. If I multiply this integral with 2, I get the limit as from 0 to pi. If I again multiply this integral with 2, I get the limit to be as from 0 to pi by 2. So that is why I have to multiply with 4. So again here also, to get the limit from 0 to pi by 2, let's multiply this integral with 4. Sine the power 4 phi d phi. Plus, this is 2 divided by 5 into 2 pi. So this is equal to 64 divided by 15. Applying the reduction formula over here, now I am having the power here 4. So subtracting the odd numbers from this power, so 4 minus 1 is 3 and 4 minus 3 is 1, divided by writing the power in the denominator and then subtracting even numbers from this power. 4 minus 2 is 2 and 4 minus 4 is 0, not required. One thing more, if the power is even, you also have to multiply this with pi by 2. But if the power is odd, you do not have to multiply with pi by 2. So we only have to multiply with pi by 2 if the power is even. Plus, this is also 64 divided by 15. Applying the reduction formula over here, again the power is 4. So it is 4 minus 1 is 3. 4 minus 3 is 1, divided by writing the power and subtracting the even numbers from this power. So 4 minus 2 is 2 and 4 minus 4 0, not required. And because it is your even number, so I also have to multiply this with pi by 2. Right? Plus, this is 4 pi divided by 5. This will go by 5. And here I am having 4 into 2, 8, 8 into 2, 16. So this will go by 4. So this is 4 pi divided by 5. Similarly, here also this will go by 5 and this will go by 4. So I'm getting 4 pi by 5 in the second term also. And the third term itself is 4 pi divided by 5. So this is equal to 12 pi divided by 5, which is the required answer.